Hello everyone. Today let's solve the Leetcode problem 230. So kth smallest element in a binary search tree, BST, right? So what the question says, given the root of the binary search tree, an integer k, return the kth smallest element, that is, it is one indexed basically. They have strictly mentioned it is one indexed of all the values of the nodes in the tree. They have strictly mentioned one thing you have to keep in mind, it is one indexed. Also, we have to return the kth smallest value, not the largest value, kth smallest value. Also, it is one indexed, they have clearly mentioned, of all the values of the nodes in the tree. So, example they have given here, 3, 1, this will be null, 3, 1, null, 2, 3, 1, 4, sorry, null and 2. And k they have given, k equals 1. So, the minimum value, kth smallest element is k equals 1. So, here that is 1, right? K will be 1, k is 1 and the kth smallest value is nothing but 1. We can visualize and see, right? The second one is 5, 3, 5, 3, 6, 2, 4 and 1, 2, 4. Then we have, then we have null and null. So, next 1. 1 k equals 3 they have given. Here we can say that 1, 2, 3. Third smallest element is 3, right? So let's write the code and I'll just take the example 1 and explain. So it will be easy to understand. So I'll just come here. So initially what we'll do, I'll just initialize an array to hold the values of the nodes. I'll just give let val equals, or I'll just take vals, so values. Just initialize the array to hold the value of nodes. Next, let's define and immediately invoke DFS function. So in my case, I'll just call the function here. Just name this DFS. Just take the parameter node. This is fine. If the vals array does not yet have the k elements, then will move to the further steps, right? So I'll just make use of if condition. If length of the vals not equal to k, then if there is a left child, we will recursively perform DFS on the left child. So this is simple. If there is a left child, then we will recursively perform the DFS on the left child. Simple. If node dot left, then function, we are recursively performing the DFS on the left child, right? DFS of node dot left. So after doing that one, we will push the value of the current node into the vals array. After recursively performing the DFS on the left child, what we will do, we will push the value of the current node into the vals array. So I'll just make use of the push here, push function, and what we are pushing, value of the node, right? This is fine. Next, after pushing the value of the current node to the vals array, what we will do, again, if there is a right child, we will recursively perform DFS on the right child. So simple, I'll just copy the same thing, this one, right? Let me copy this one and make the necessary changes here. So I'll just come here. Let me make this node dot right. So DFS of node dot right. This looks good. Next, what we will do, we will start the DFS from the root node. So we are starting the DFS from the root node. The first node, the main this is called the root node, right? We will in this example we'll start the DFS from root node. I'll just come here. Let me give root here, over here, right? So next, after this, what we will do, this is fine. Let's return the kth smallest value. Nothing but the kth smallest value here is k equals 1. So the value is 1. We are returning the result, right? So that's the output here that we want. So we know that the array is 0 index. So index starts from the 0, right? So k minus 1, we can make use of the k minus 1. So I'll just come here, just give return vals of k minus 1. So yeah, let me hit the submit. So this works well, right? So let me take this example. Yeah, here what we are doing here initially. So we have initialized the vals, right? We have sorry, just give me a second. Yeah, we have initialized vals, right? Next, the function we are starting the DFS from the root 3, this one, right? So we will start the DFS from the root 3. So now node is 3 and the vals dot length is not equal to k because this is 0, right? Now the length of just this one, we are just considering this root node. So now the length is initially 0. So according to this one, vals dot length is not equal to k. K equals initially 1 and the vals length is 0, right? I'll just length of the vals length, I'll just give VL. This is 0 initially and k equals 1. So we will continue. So we will continue this one. If node dot left, we will perform the recursively call the DFS of 1, right? What we will do initially, left child of 3 is nothing but 1. This one. When now we will recursively call the DFS of 1. If node dot left, DFS of left we have given, that is nothing but 1. So now the left child 1. Next this one, right? It will go to this one. We have null here. So this one is nothing but null. I'll just put n here for null. So we have no left child, so we have considered this one just as null. Next what we will do, we will process node 1, nothing but this one. We are pushing the vals dot push to node dot val, right? So what we will do, now vals is 1, this one. Now we have the vals. Within the vals, the value we are having is 1 now. Sorry, I'll just consider this 1. So again we will check this one. If vals dot length not equal to k, so the length of the vals is now 1. We have 1, right? Now the length is 1 and 1 is equal to k. Basically we have the k 1 here. So what we got here now, 1 equals 1. So what we will do, we will stop further DFS and return from the recursion, right? So although we are having this one 2 and we also have the 4, we are having 3 and we are having the right child 4, right? This exists. We are not processing further since length of the vals is equal to k, right? 1 equals 1 we got, right? So what we are returning vals of k minus 1, nothing but this value we are returning, right? What we have got now, we are returning the output as 1. So the output for here also we have got is 1. Same thing, right? Same goes with the example 2. So yeah, this is it. Then what would be the time complexity and the space complexity? So the time complexity, just give me a second. So yeah, the time complexity would be big O of n. Why the time complexity is big O of n? We are performing a depth first search, nothing but DFS on the entire tree, right? Nothing but we are visiting each node exactly once, right? So the time complexity would be big O of n. And the space complexity would be big O of n as well. Why the space complexity is big O of n? We are making use of the vals array, which will store up to n node values in the worst case. Also, we are making use of the recursive call stack, right? That can go up to the n levels deep into the, deep in the worst case. So the time complexity as well as the space complexity would be big O of n. I'll just come here and mention time complexity big of n, space complexity could be big of n as well. So I'll just comment this one. Let me submit the code once again. So yeah, this is it. Thanks for watching, guys.